Okay, in this video, I will go through section 2.2, modeling with the Poisson distribution. In order for the Poisson distribution to be a good model, the events must occur 1. Independently, 2. Singly, in a space or time, 3. At a constant average rate, so that the mean number in an interval is proportional to the length of the interval. Let's go through an example first. Example 4 from the textbook. An internet service provider has a large number of users regularly connecting to the internet. On average, 4 users every hour fail to, so 4 users every hour, fail to connect to the internet at their first attempt. Given A, give 2 reasons why a Poisson distribution might be a suitable model for this number of failed connections every hour. So it says, first of all, it says every hour, which is good indication for this to be a Poisson distribution. Okay, so for okay, so A, 2 reasons why this could be modeled as a Poisson distribution. So we could say failed connections occur singly, okay, one at a time, okay, at a constant rate of for every an hour. So 2 reasons why this is a Poisson distribution. However, the third one could be they're happening independently. Okay, happening one fail doesn't mean the next one wouldn't happen, or it doesn't mean the chance of next fail would reduce or increase. Okay, so part B. Find the probability that in a randomly chosen B part 1, 2 users fails. Okay, first of all, we have to model it as a Poisson distribution. Let x be equals to the number of failed connections failed connections. We have to specify the rate as well in every an hour, in 1 hour. Okay, so in this case lambda would be equals to 4. The rate of fail is 4. Therefore x follows the Poisson distribution with lambda of 4. Okay, now we want to work out 2 users fail. Probability of randomly chosen or random variable x is equals to 2. Using our calculator, okay, for PD and variable, x is equals to 2, where lambda is equals to 4, which we get 0.1465. Okay. Part 2. More than 6 users fails to connect at their first attempt. More than 6 users fail. Okay, for more than 6 users, probability of random variable x is greater than 6. Since it is greater than, I draw a number line. Okay, let's say here is 0, 1, it goes up to 6, 7, 8, and so on. More than 6 means 6 is not included. 7 is part of the answer, 8 is part of the answer, 9 is the part of the answer, 10, and so on. So we know that we won't be able to calculate for greater than by using calculator or the table. So what we could do is, obviously we know the total probability it continues forever is equals to 1 minus. If I take away probability of x equal to 0, 1 up to 6, probability of x less than or equal to 6, then I will get probability of x greater than 6. Okay, so less than or equal to 6, because 6 is not included in our solutions. So therefore, let's go to setup, and this time we need Poisson CD. Okay, because we are looking for less than. Number 3, so variable, and then x is equal to 6 and lambda is equal to 4. Therefore, 1 minus 0.8893. So this is 0.1107. Okay. So now let's move on to the part C. Find the probability that in a randomly chosen in 90 minutes period. Okay, first of all, I write it down because the period of time has been changed now. Find the probability that in randomly chosen 90 minutes period. 1. 5 users fail to connect. Okay, to do this, first of all, the period of time has been changed from 60 minutes to 90 minutes. And we know the rate of fail, which used to be 4, it was for an hour. So we have to define new variables, such as y. Let y represent the number of fails, okay, the number of failed connection, the number of failed connection in every 90 minutes on average. So if it's the case, then new lambda would be equal to 6. Because if it fails in average, if 4 connection fails in an hour, 6 connection will fail in an hour and a half. Okay, so we don't really know where is the position of the failure. It could be in first minute and 60th minute, or it could be in first minute and second minute. But in average, 4 connection fails in an hour, so therefore 6 connection fails in every an hour and a half. Okay, so therefore y follows the Poisson distribution again with parameter of lambda or 6 in this case. And we are looking for 5 users failed. Probability of x equals to 5. Okay, so let's use the calculator again. Okay, Poisson PD, and x is 5, lambda is 6. This is 0.1606. Okay, part 2 of question B. Fewer than 7 users fail to connect. Fewer than 7 users fail to connect in every 90 minutes. So fewer than 7, meaning probability of random variable y is less than 7. So less than 7. 7 is not inclusive, therefore it would be less than or equal to 6. So it is discrete random variable. What we mean by discrete, there cannot be 7.5 fails. It could be either 7, 6, 5, a whole number basically, integer. Okay, now using the calculator again. Okay, so we are looking for less than, therefore cumulative distribution, which would be 3, 2, okay, x is, in this case, y is equal to 6. However, we don't have option in our calculator to represent y. Okay, and lambda is equals to 6 again, which is 0.6063. 0.6063. Okay, end of the section 2.2, and you will be able to do exercise 2C, which is page 24, 25, 26, and 27. Okay.